So this video is on section 9.1. It's called Intro to Logic. And first thing I wanted to do is just talk about our big goals in chapter 9. So we've got two goals here. First goal, we want to break down compound statements into simpler parts. So when I say compound statement here, just imagine something like a complex or complicated statement, such as you might see in a legal document. We want to take those long statements consisting of several parts and break them down into simpler parts to make it easier to analyze. And our second goal is to figure out when a compound statement is true or false. So over the course of chapter 9, we're going to develop a framework for being able to answer that question. So first thing we're going to do is define what we mean by a simple statement. So a simple statement is a sentence that is either true or false. You could rephrase that as saying a simple statement is a sentence whose truth value can be determined. So in a simple statement, everyone could look at that statement and all agree on whether that statement is true or false. Let's see some examples of some simple statements. So a simple statement could be something like, water freezes at 23 degrees Celsius. Well, that statement is false. I'm just going to write capital F for false. But everyone who looks at that statement would read that and agree that that's false. So it's a simple statement because the truth value can be determined. For part B, we've got another simple statement. -2 is less than 3. That is a true statement, so I'm going to write capital T for true. Everyone who looks at that statement would be able to evaluate that and say, yes, that's a true statement. So there's no debate in a simple statement about whether it's true or false. We would all agree. Let's look at some examples of sentences that are not simple statements. So part A, tomatoes are delicious. Okay, I predict that this could be quite a contentious topic. Some people would probably strongly agree with this. Some people would probably strongly disagree. The problem here is that this is an opinion, and an opinion is never going to be a simple statement. We will not agree on the truth value. Something like 2x plus 1 is at least 7. That depends on x. So for some x values that would be true, for some x values that would be false. Therefore, we can't assign a truth value to that. So that's not a simple statement. Part C, anytime we have a question, something like, is it raining? That's not going to be a simple statement. The reason is that this sentence here actually doesn't contain any information. It's asking for information, but it doesn't contain any information. And therefore we can't give it a truth value like true or false. For part D, let's say you're talking to your dog who's barking loudly or something and you say, be quiet. Well, that's an order. Again, does not actually contain information. We're just commanding something to happen, but does not contain any information. Therefore, we can't assign a truth value to that. So anything that's an opinion or depends on some other information or is a question or an order, those types of sentences are not going to be simple statements. So we're going to restrict ourselves just to the simple statements, the type that we saw up at the top of the screen here, where we're making statements where everyone would agree on the truth value, whether it's true or false. So now that we understand what a simple statement is, we can start to work towards the idea of compound statements. So for short, we're going to let the symbols P and Q represent simple statements. If we had 3 simple statements, we might use P, Q, and R, for example, to stand in for those simple statements. And we're going to start to take a look at what we mean by compound statements. Okay, so we're actually going to see 4 compound statements here. And our goal right now is just to read through these, make sure they make sense, and to introduce a bit of notation so that we can write these down more quickly. So let's start with the idea of P and Q. All right, so if we want to say P and Q, we're going to use this symbol here. For the and, it's an upside down V. So read that as P and Q. Second compound statement is the OR operation that joins two simple statements. With the OR, there's a bit of a subtlety here. When we say P or Q, we really mean P or Q or both. So that OR is always including the possibility that both things could be happening. And to represent that, we're just going to use a V. So the V is for the OR. The AND uses the upside down V. So something that might help you remember this notation is you can draw a parallel to sets. Remember, we used the intersection for the AND back in chapter 3 when we were talking about sets. So the intersection was like that. And you can think of there being a parallel between the intersection and the AND operation. Whereas for the OR, when we were talking about sets, we wrote a union like this, A union B. And when we talk about logic, it's actually more like a V symbol here as opposed to a U. But the idea is that the symbol is opening upwards in the case of the OR, and it's opening downwards in the case of the AND. So that parallel might help you with learning the symbols. All right, so a couple more of these compound statements to look at. Sometimes we want to negate a certain statement, meaning to say it's not true or it didn't happen. So not P, we're just going to write with a little tilde in front of the P like that, or a little squiggle in front of the P. That's our not symbol. And then fourth and final compound statement that we're going to practice today is the if-then structure. So if you say something like if P, then Q, we're going to represent that in terms of notation with an arrow. So we're going to say if something, then something else. We put the something first, the something else second, and we just draw an arrow going to the right. We read that as if P, then Q. Sometimes you'll see that reworded as P implies Q. We'll talk about that a little bit later in section 9.3 in more detail. But I mentioned that now just in case you've seen something like that or you're used to thinking in those terms. You could say P implies Q if that's easier for you. And then maybe you see more of a direct connection that way with the notation. So P implies Q is just written P, arrow to the right, and then Q. So what we want to focus in on today is to look at a variety of compound statements that are written out in words for us. And we want to practice just using our new notation and boiling those compound statements down to just a symbolic representation. So we just want to write them symbolically using our new notation. So here's our big example for this section. Imagine that there is a party going on. So this party is happening sometime in the future when physical distancing is over, because right now, I think we all know parties are not cool, but at some point in the future, there will be parties again. And statement P is representing the fact that Paula is going to the party. Q is going to represent the fact that Quinn is going to the party. So we have these two people, Paula and Quinn, who may or may not be going to the party. So what we're going to do in this example is we're going to write the following statements symbolically, and we're going to go through 10 different parts here, see a variety of compound statements, and we're just going to be practicing our notation. So here we go, part A. So I think I'll put each of these just in a little box as we go to help keep it organized. All right, so Quinn is not going to the party. Well, the statement that encodes Quinn is going is Q, and if we want to negate that, then we use this tilde symbol. So not Q is how we would write that symbolically. All right, second statement here. It is not the case that Paula is not going. So that's a double negative. Not the case that Paula is not going, could be written like that. Alternatively, you could just say P, because a double negative is just taking us back to our original statement. So you could write not P, or you could write P. If you write P, then you're saying Paula is going, which is just a rephrasing of that statement. All right, Quinn and Paula are both going. So that's Quinn is going and Paula is going. So we use the upside down V for the and operation. Alternatively, you could write P and Q. So with the and operation, doesn't matter which order you write these in, Q and P or P and Q, that's saying they're both going to the party. Okay, part D, Quinn or Paula is going. And if you want to rephrase that, you could say at least one of them is going. So that means one of them is going or two of them are going. That captures all of those situations, because the or operation here always includes the possibility of both things happening. So Quinn is going and Paula isn't, or Paula is going and Quinn isn't, or they're both going. So all of these situations can be captured just by saying Q or P. Alternatively, another answer would be P or Q. So with the or operation, it doesn't matter which order you write those symbols in, Q or P is fine, P or Q is fine. They both capture the situation where at least one of these guys is going to the party. All right, part E. Paula is going, but Quinn is not. Okay, well, this one's a little subtle. The subtlety has to do with language, which is a little messy. When we say but, that is really just another way of saying and. We often use the word but when something negative is coming afterwards, but from a logical point of view, but is just an and operation. So we would say Paula is going and Quinn is not going. And if you want to make that easier to read, you can put brackets around the not Q if you like. So Paula is going and Quinn is not going. So just think about turning that word but into an and that's a solid way to always express these ideas symbolically. Okay, part F, they are not both going. Could be none of them are going. Could be one of them are going. So a way to rephrase that is to say at least one of them is not going. One of them is failing to go. Could be both of them are failing to go. Could be one of them is failing to go. But in the end, we're going to have 0 or one of them going to this party. So I would say the most direct way to do this is just to say not P and Q. P and Q is representing them both going, and if you negate that, then they're not both going. But there is an alternative way to think about it. So sometimes people have a preference in considering it one way or the other. You could say not P or not Q. So you can pass the not onto the individual statements, but notice that now we've got the or. Oh, sorry, I meant to highlight that. But now we've got the or joining the two symbols if we write it this way. So if we write it as not P and Q, then I would say we are literally translating they're not both going. Whereas if we write not P or not Q, then we're more saying at least one of them is not going. Paul is not going or Quinn is not going. At least one of those statements is true. So two different ways of thinking about the same idea. A lot of the time, there's potential for miscommunication in language, which comes down to just, let's say, a misinterpretation of logic. So, I mean, really, we've got two different ways of saying the same thing. And if we have a clear understanding of logic when we're communicating with other people, whether we're writing or we're talking, if we have a clear understanding that these two things are the same, then that can alleviate a lot of confusion. Okay, part G, neither of them is going. So I would say that means Paula is not going and Quinn is not going. You could rephrase this as 0 of them are going. So not P and not Q. Alternatively, if you prefer another way to say this, you could say not P or Q. So if you say it the first way, you're saying Paula's not going and Quinn's not going. If you say it this way, then you're more like saying it's not the case that Paula or Quinn is going. So two different ways of saying the same thing. I would say the first way is preferable, but just in case you're wondering about different ways to word it, we've got those two options there. So they're both correct. Okay, part H. Paula or Quinn is going, but not both. Well, remember we talked earlier about the fact that but can be rephrased as an and. So there's going to be an and in here. And we've already talked about the idea that they're not both going. So not both would be not P and Q. So that's our not both. We did that in part F. So you can look back here at part F to think about that second part there. And then the first part of the compound statement is saying Paula or Quinn is going. So I would say that as P or Q. P or Q, and not both of them. So this one is really a skill testing question there. That's probably the hardest out of the 10 statements that we're going to do, just because it relies on a few things that we've done before. So I've broken that up into Paula or Quinn is going and not both. So here's our, I'll highlight it as we go. So Paula or Quinn is going and not both of them is how you would write that. Okay, now we're going to do two more, just practicing the if-then structure. So if Paula is going, then Quinn is going. Well, to represent the if-then structure, you write the first thing and then the second thing with an arrow going to the right. So if Paula is going, then Quinn is going. We'd write it like that. And last one that we're going to practice here, if Quinn is going, then Paula is not going. Okay, feel bad for Quinn in this scenario. So if Quinn is going, then it's not the case that Paula is going. And if you wanted to make that more clear, more easy to read, sometimes we'll bracket around that. We'll talk more about bracketing as we go through this chapter. So there we go. We've practiced 10 different compound statements here. It really came down to our 4 new pieces of notation, which were the and, the or, the not, and the if-then construction. So that's the end of our Intro to Logic section. Thanks for watching.